Every list, string, and dictionary you have ever used was built for you by a constructor, a special function that runs the moment an object is created. Today we write one ourselves. It carries a strange name dunder init and a stranger first parameter, self, a name for an object that does not exist yet. Make sense of self, and classes make sense. Last video ended with Python knowing that a type called coordinate exists. Its body is still empty. The first thing that goes into that body is the constructor, the function that tells Python how to build a coordinate. And defining one is always the next move after the class header. The constructor has a special name, init, with 2 underscores before it and 2 underscores after it. Those underscores are genuinely part of the name. Functions named this way are called dunder functions, short for double underscore, so this one is dunder init. Look closely at the line and it is recognizably a function. The keyword def, a name, parentheses with parameters inside. Only one detail separates it from every function we have written so far. The first thing inside the parentheses is self. Here is the basic idea of self. Self is always the first parameter of a method, a function that only works with an object of this class. The reason it exists is a matter of timing. When Python reads a class definition, we are only describing a type we would like to have. No coordinate has been created. There is no actual object to manipulate. Yet the definition has to talk about the object it will one day build. Its data, its behaviors. So we need a name that refers to an instance without having one in hand, and that is exactly the job self does. Inside the class, self means the object itself, my data attributes, my methods, whichever instance this code eventually runs on. Everything after self is a parameter you create the object with. For a coordinate, the choice is natural. A coordinate lives in a two-dimensional plane, and creating one means placing it somewhere specific in that plane, so it needs an initial x value and an initial y value. It makes no sense to build a coordinate without them. That is why the constructor takes 2 more parameters, named xval and yval. Listing them in the parentheses tells Python that whoever creates a coordinate must pass in a value for x and a value for y. No values, no object. The body of dunder init holds whatever code initializes your object, and 99% of the time that means one thing, setting up the data that makes up the object. We already decided what data makes up a coordinate, how far along the x-axis it sits, and how far along the y-axis. So the body is 2 assignments. Self.x is set to xval, and self.y is set to yval. Read the first one right to left. Take the value that came in as xvals and store it as the x data of the object being built. A short docstring records the job in plain English, sets the x and y values. The self dot in front is what distinguishes the object's data from ordinary variables, and that prefix does more work than it appears. To see why that prefix matters, consider the alternative. Suppose the body said plainly, x equals xval and y equals yval, with no self dot in front. Those would be ordinary local variables of the function dunder init, exactly like a local variable in any function you have written. The moment dunder init terminates, those variables are gone, and the values that were passed in vanish with them. The object would come out of its own constructor holding no data at all. Because the code instead writes self.s and self.y, the values are stored on the object itself, and they persist throughout the lifetime of the object once it is created. And the class will be used to build many objects over time. Every single object created from it carries its own x and its own y. These 2 lines invite a natural question. Does the attribute name after self.dot have to be different from the parameter name, xval? It does not have to be. You could write self.xval equals xval and the self.yval equals yval. and the class will behave identically. The names were made different here deliberately to showcase that they are completely independent of one another. Self.x is one thing, the attribute, the object's own data, named however you like. Xval is another, the parameter, the incoming value. The assignment simply hands the parameter's value over to the attribute. Here is the analogy that makes self click. A blueprint for a room. The room does not exist. The blueprint is only an idea on paper. But it promises that any room built from it will contain 2 chairs, a coffee table, and a sofa. Right now, there are no rooms, no chairs, no tables anywhere. Self is how the blueprint refers to its own attributes. Writing self.coffeetable means when an actual room exists someday, this refers to that room's coffee table. Ask for a room to be built and call the result living room. Now you hold a real room, so you refer to its table as livingroom.coffeetable. The living room's coffee table, not self's. Self never appears outside the blueprint. One more thing makes blueprints worth drawing. A single blueprint can produce many rooms. Build a second living room from the same sheet, and it has different chairs, a different coffee table, different colors, completely distinct instances stamped from one template. One idea holds this whole video together. While a class is being defined, no objects of that type exist. The definition only tells Python, here is a type I would like, and this is the data and the behavior bundled inside it. Dunder init is the recipe that runs when an object finally gets created. Self is the definition's name for that future object, which is why self.x equals xval. Stores an incoming value as data the object keeps for life. Under an attribute name, you're free to choose. Next, we use the class. We create actual coordinate objects and watch dunder init run. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.